Now we're going to go a little bit further into simplifying rational expressions now, and the steps for simplifying a rational expression are as follows. You don't necessarily have to determine the domain. That is strictly for when you're solving an equation, but it's good to be thinking about the restrictions at this point just to be in practice to do it. So we would be excluding values that make our denominator equal to 0 if we're solving an equation. Otherwise, we're going to completely factor the numerator and denominator. If there are any common factors, those can be reduced, and that's important to do. Now we'll simplify rational expressions. In example 1, we have 36x to the 5th divided by 42x squared. So what we're trying to do is with the numerical coefficients 36 and 42 is see if there's any common factor. Then with the variable bases x to the 5th and x squared, we're going to see if there's any amount of x in common. So what we might do to start off with is take the number 36 and think of some factors of 36, like 6 times 6, and then I'll keep my variable x to the 5th. Now what I'm hoping will happen is that 42 will have 2 factors, and one of them hopefully is 6. So 6 times 7 actually will make 42. And we'll keep our variable x squared. So now you can see that a factor of 6 is a common factor to reduce. That leaves 6/7, and there are no more common factors there. So the next step would be to use our quotient rule with these like bases of x. I would compare 5 and 2 and see that x squared has the lower exponent. So this term is going to shift across the division bar, and when that happens, the exponent becomes the opposite sign. So I have shifted x squared into the numerator as x to the negative 2. I can then use my product rule and add these exponents of 5 plus negative 2. So I end up having 6 as a coefficient in the numerator. X to the 5 plus negative 2 means x cubed. And in the denominator, all we have remaining is a coefficient of 7. So our final answer is 6x cubed divided by 7. In example 2, you can see this is written a little differently because the numerator is now a binomial. It's got this minus sign separating the two terms. So what we want to try to do for this rational expression to see if there's any possible reducing is make sure that both the numerator and denominator are factored completely. In our numerator, I can see that the coefficients of 3 and 6 would have a greatest common factor of 3. Then I would compare the variables, x with x squared. So obviously both of those terms have x. Then to recreate those original terms, we're going to use the distributive property. 3x multiplied by 1 would match 3x. And then 3x multiplied by a negative 2x would match negative 6x squared. In our denominator, we have a monomial term. That means one single term, 3x. So we might be able to see that the factor of 3 divided by 3 reduces. Factor of x reduces with x, and that leaves a term only in the numerator. So it's like it is being divided by 1, because when we reduced 3x by 3x, that really reduces to 1 over 1. So if we are dividing by 1, then that's not going to change the value of our terms in the numerator. So we simply write 1 minus 2x. For example 3, we have a trinomial in the numerator and we have 4 terms in the denominator. So 4 terms, remember, we're going to have to do some grouping in that denominator. But as far as the numerator is concerned, it's written from the highest to the lowest power. Unfortunately, we don't have perfect squares to make this quick, so we'll have to use the sum and product technique for that numerator. going to look at a sum and product. In the middle, we've got negative 5. 3 times negative 2 would give us negative 6. So you might be thinking, oh, 6 is 2 times 3. One of those factors would need to be negative. To add to something negative, the larger would need to be negative. Unfortunately, 2 plus negative 3 is not going to give us negative 5. So the only other factors to think about are 1 times 6. Again, the larger factor should be negative in order for these to add to something negative. 1 added to negative 6, that does match our minus 5. So positive 1x and negative 6x are going to replace the middle term. We have 3x squared plus x minus 6x minus 2. We have grouping now. In our first group, x is in common, leaving 3x plus 1. That means 3x plus 1 should be the common factor in our second group. 3x times something needs to match negative 6x, so it looks like we need minus 2. Is 1 times negative 2 a match for the last term? So our common factor is 3x plus 1 in the numerator, and x joins with minus 2. Okay, so that's the numerator of our rational expression. Now we'll work with the denominator. For this grouping, I can see that x is in common, and I have x minus 2. So x minus 2 needs to fill in the other quantity. X multiplied by something has to match positive 5x. And negative 2 times 5, that matches the minus 10. So common factor here is x minus 2 times the quantity x plus 5. This is the denominator. So when I rewrite my rational expression, I'm putting 3x plus 1 times quantity x minus 2 in the numerator, and then quantity x minus 2 times quantity x plus 5 in the denominator. The last thing we want to look for is if any of these factors are identical for the numerator and denominator to reduce. So it looks like 3x plus 1 does not match either one of the factors in the denominator. However, x minus 2 is found in both locations, so that quantity is reduced from the problem. Our final answer is quantity 3x plus 1 divided by quantity x plus 5. So it is involving several steps, and it gives you a good workout with all of the different factoring techniques. All right, in our final example today, it says, what happens when terms within factors are written in reverse order of each other? So this might happen with some of the problems you have in your homework. So let's see what that's talking about. In our numerator, we have just two terms, 18a minus 12a squared. I don't see perfect squares here, so it's not difference of squares. We could use greatest common factor here. So the numerator with 18 and 12, I know 18 is 6 times 3, and 12 could be 6 times 2. So that's helpful to know that 6 is common. And it looks like we also have some variable in common. 6a is the greatest common factor. That would leave us 3 minus 2a. So 6a times 3 matches 18a. 6a times negative 2a would match the minus 12a squared. That's completely factored. Our denominator, 4a squared minus 9, you might notice is a difference. It is subtraction. And 4 and 9 and a squared, those are all perfect squares. So we know that we have a difference of squares. We can go directly to the factors by thinking about square root of these terms. 4a squared is 2a times 2a. 9 is 3 times 3. Since there's no first degree term, we need one of each symbol in order for these middle and outside terms to add to 0 and eliminate. So going back to the question, what happens when terms within factors are written in reverse order? Well, do you notice how this quantity of 3 minus 2a is the reverse order of 2a minus 3? So they're not exactly the same. We cannot reduce them the way they are given. However, we could factor out -1, and then that would reverse the order. So let's see how that works. Down here, if we start with 3 minus 2a, if I factor out a -1, then I'm going to use the distributive property to recreate that term. -1 times -3 would match that first term. -1 times positive 2a would match minus 2a. So if I take the terms that are in this quantity and just reverse that order, let's put 2a first and the minus 3 last. Do you now see how this quantity is written in the same order as the quantity in the denominator? So that's going to be very helpful to us. In our numerator, 6a remains the same, but I factored out a -1, and that reverses the order of the terms given. So 2a is now first, and -3 is last. The denominator is not changing. 2a plus 3 times quantity 2a minus 3. So now we can see we do have, in fact, identical quantities that reduce out of the problem. And what I'm left with in the numerator is 6a times -1 minus 6a. Denominator is just that quantity of 2a plus 3. And this is the final answer. Now, don't be tempted to start crossing out these terms with a, because the denominator is a binomial. These terms are connected with addition, so they are not factors. Only factors reduce. So we cannot reduce these a's. We can't reduce 6 with 2 or 6 with 3 for the same reason. Because of the plus sign given here, we do not have the denominator written in factors. They are actually called addends. You probably haven't heard that word since grade school. So don't be tempted to start crossing things out just because they're multiples of each other. If it's written with plus or minus, you will not be able to do that reducing. So I hope you found this video helpful, especially with factoring out -1 to help you reverse your binomial order.